welcome back. Today we're going to be going over Cartesian coordinates to polar coordinates and how to go in between them. So first off, we're going to go over what Cartesian coordinates are. Cartesian coordinates are coordinates that use a pair of values of x and y to represent a point in a 2D plane. So if we have a point right here, Cartesian coordinates would tell us that this x value is 4 and our y value is 3. So we could have it as 4 and 3. The x coordinate represents the horizontal distance from the origin, which would be right here, and the y coordinate represents the vertical distance from the origin, which is right here. Now, the difference between them is the polar coordinates don't use x and y values. Instead, they use an r and a theta value. The difference being, if we have a 2D object here, the r value is going to be the distance from the point to the origin. So let's say we have the point here. The r value is going to be from the origin to the point, and our theta is going to be measured from the positive x-axis to the line connecting the origin to the point, meaning we'll have our angle here being theta. And that's how we're going to read it. So if our angle is 35 degrees and our r is 6, instead of having an xy, we'll have 6 and 35. Now, the way to convert from Cartesian coordinates of x and y to our new polar coordinates of r and theta, in order to find the r value, we have to use the Pythagorean's theorem. Because if you think about it, if we have our x and y here, our imaginary x there, and our imaginary y, but we're looking for this right here, we can see how it would make a triangle. So we need to use the Pythagorean theorem to find our r. So r will be the square root of x squared plus y squared, because we're finding what is our hypotenuse of the triangle. And in order to find theta, what we need to do is we need to take the inverse tan of y over x. And that's because if you remember SOHCAHTOA, we can remember TOA is TOA, meaning opposite over adjacent. If we have a point here, and we have our y value and our x value right here, and we need to find our hypotenuse, and we're looking for this angle, because that's what we need in polar coordinates, we know what our opposite is, because that's our y value, and we know what our adjacent is, because that's our x value. So that's the reason we need to use this to find our angle. And same thing with the r value. So I have our first example here, which is going to be the x value of 3 and our y value of 4, and we're going to put that into polar coordinates. So the first thing we need to do is find r, which, if you remember, is just the Pythagorean's theorem. And it's going to be x squared plus y squared. So we're going to have 3 squared plus 4 squared, which will give us the square root of 9 plus 16, which gives us the square root of 25, which lets us know that our r is going to be equal to 5. And the next thing we're going to have to do is we're going to have to find our theta, which is going to be equal to the inverse tan of y over x. And our y here is our 4, so we're going to have 4 divided by 3. And we're going to use radians for this example. And we know that we just plug this into a calculator because we don't have it memorized, and this will give us 0.93 radians. So instead of having our 3 and 4 are x, this is going to become 5 and 0.93. Alright, now we're going to be going from polar coordinates of r and theta to Cartesian coordinates of x and y. So in order to find the x value, what you have to do is you need x is equal to r multiplied by cos theta. Again, because of triangles, so I'll draw it out, because we'll have our r here, which will be our hypotenuse. And then we have to find our x-axis, or our x and our y. But we know our angle. And since we know our angle, we're able to use, this comes from our trig properties because we have k, which is adjacent divided by hypotenuse is cosine. So we have cosine is equal to adjacent over hypotenuse. And we already know what our adjacent is it's going to be x. And our hypotenuse is going to be h, which in our case is going to be r. So this means that our cosine of theta is really equal to x over r. And in order to isolate for x, all we have to do is multiply both sides by r. So these will cause this to cancel to give us x is equal to r multiplied by cos theta. And next up we have finding our y value, which is going to be equal to r multiplied by sine theta. And this is kind of the same thing as finding x. We have SOH, so we have SOH. Instead of it being x over r equaling cos theta, we're going to have sine theta is equal to y over r. And same thing, multiply both sides by r, giving us y is equal to r multiplied by sine of theta. And now we're going to do converting the polar coordinates to Cartesian coordinates with the same numbers we had from before, so we'll know if we're right. So we'll have our x is equal to r multiplied by cos of theta, which is going to be our angle. So r here is 5, and it's going to be multiplied by cos of 0.93, which if you check into a calculator will approximately give you 3. And we have y is equal to 5 multiplied by sine of 0.93, because it's r and this is our theta, and this will approximately give you 4. And this will approximately give you 5 multiplied by 0.6, which will give you 3. And y is going to be equal to 5 multiplied by sine of 0.93, which will approximately give you 5 multiplied by 0.8, which will give you 4. So our new Cartesian coordinates are going to be 3 and 4. Alright, and to wrap it up, we're going to do some special cases. So our first special case is having a negative r. And the difference here is because if you remember, our theta is going to be the positive x value to where our r line is. If we have r going into the opposite direction, we have to know that our theta, instead of it just being here, we're going to have to make sure to add or subtract pi or 180 degrees, because this is what's going to be our theta. And another thing to keep in mind while doing some questions is ensure that if you're using radians or degrees, to keep them consistent throughout your questions. You can't switch between them just randomly unless you do the calculation for it. So just keep them, if the question's asking in radians, keep it in radians, and if the question's asking in degrees, just keep them in degrees.